Bismillahirrahmanirrahim. Assalamualaikum and hello guys. Okay, so in this video I will only cover one part from the 5.4, which is we are going to find equation of a plane. Okay, so there are two types of equation. The first one is the vector equation and another one would be the Cartesian equation. Okay, so remember that for the equation of plane, there is remark over here that you need two things to find the equation of a plane, which is the first one you're gonna need a fixed point, any fixed point on the plane, and then another one you will be need a normal vector n. Okay, any normal vector or any vector that is perpendicular to your plane. Okay, so I divided the equation of plane into three cases. So let's go through the first case. So let's say we have a plane in space with normal vector n. Again, normal vector is any vector that is perpendicular to your plane. Okay, let's say this is the normal vector and the coordinate would be A, B and C. Okay, and then our plane also pass through a fixed point A, which is, let's say this is our fixed point. I label it as A with coordinate x1, y1 and z1. Okay, so same as equation of line, we're gonna have a random point on the plane, which is I label it as R with coordinate x, y and z. Okay, so this is any random point on the plane, this is any fixed point on the plane, and this is any vector that is perpendicular to your plane. Okay, so now let's together find the vector equation first. The vector equation of your plane. Okay, so looking at our diagram here, we see that we can actually conclude that the vector AR, which is on the plane, the vector is actually perpendicular to vector n. Okay, we know that vector AR is perpendicular to vector n. Okay, so remember that if two vectors are perpendicular to each other, meaning that their dot product gonna be 0. So AR dot n is equal to 0. So AR is equal to OR minus OE dot n equal to 0, and then OR we can write it as small r minus small a dot n equal to 0. And then using the properties for dot product, we can expand this one, become r dot n minus a dot n equal to 0. And then I bring the a dot n to the other side, we can have r dot n equal to a dot n. Okay, so this is the equation of the vector equation of your plane. Okay, which is the a, which is the fixed point, and also the normal vector will be given, or you're gonna have to find it. So the dot product of these two gonna be constant. So your final equation for the plane should be r dot n equal to constant. Okay, because this is the dot product of two vectors, so you're gonna have a constant. Okay, so this is the vector equation for our plane. Now let's together derive the Cartesian equation for our plane. Cartesian equation. Okay, so same as equation of line, we're gonna change our equation in terms of column vector. Okay, so for R we have coordinate x, y and z, and then for n we have a, b and c, and then equal the coordinate of any fixed point is x1, y1, z1, and then we got a dot again with the normal vector with coordinate a, b and c. Okay, so the dot product for the left hand side would be ax plus by plus cz, and then for the right hand side would be ax1 plus by1 plus cz1. Okay, so again, since you will know the normal vector and the fixed point, okay, so this part will be actually be a constant. So ax plus by plus cz is equal to a constant. Okay, so this is the Cartesian equation of your plane. Okay, so now let's see the second case, which is a plane passes through 3 points. Okay, let's say I label the 3 points as A, B and C. Okay, so remember that for our equation of plane, we're gonna need a fixed point. Okay, so you already have 3 fixed points, so there's no problem with the fixed point. So how about a normal vector? Okay, so you don't have normal vector over here, right? Okay, so we need normal vector in order to do the equation of the line. equation of the plane. So how do we find the normal vector? Remember that we learned the cross product. So let's say I have vector AC and AB, the cross product of these two vectors gonna be perpendicular to the two vectors. Okay, so that is your n. Okay, so the cross product for the two vectors is gonna be your normal vector. So that is actually three possible normal vectors. The first one would be, let's say we have AC and AB. So your normal vector gonna be AC cross product with AB. Also, let's say we have BC and BA, the vector BC and BA, so you can cross product the two vectors, which is BA cross product with BC. Or another case would be if you have vectors CB and CA, you can cross product the two vectors, so your n can also be CA cross with CB. Okay, so that's how you find the normal vector if you are given 3 points. Okay, so for the last part, you're gonna have a plane that has two vectors or two lines. Okay, so let's first we look at the first plane. So let's say we have two vectors. The first one would be, let's say, the vectors P, and another one the vectors Q. Okay, and with a fixed point given. So let's say this is a fixed point over here. Okay, so what we don't have is the normal vector. So again, how do we find a vector or a normal vector that is perpendicular to the plane? We can just simply cross product two vectors. So in this case, you can find your n by cross product the two vectors, just P cross with U. Or you can also cross Q with your P. Okay, so you're gonna have two options to find your normal vector. Either it is upwards or it is downward, as long as it is a normal vector or a vector that is perpendicular to your plane. Okay, so now let's say we have two lines. Let's say this is L1, this is L2. So remember that in previous lecture, we learned that for the L1, we're gonna have equation, for example, R equal to B plus T V1. And for the line 2, you're gonna have, let's say, line Q equal to C plus lambda Vj. Okay, alright, so we already have fixed point from the line, which is we can use B or C as fixed point on the plane. So what we don't have is we don't have the normal vector of the plane. Okay, so notice that for the line we have the direction vector V1 and we also have direction vector V2. So meaning that the V1 would be somewhere here. Let's say this is your V1, and also you have V2, let's say in this direction, okay, as long as it is parallel to your line. Okay, so how do you find the normal vector? Again, remember that you can find the vectors that are perpendicular by using the cross product. So meaning that you can find your n or normal vector by cross product the two direction vector. Okay, so that's how you get the normal vector. Okay, now let's go through these three examples. Okay, so example 13a, they ask us to find the vector and Cartesian equation of a plane with normal vector and also containing the point -1, 2, and 4. So meaning that we already have the information needed, which is we have the normal vector and we also have the fixed point on the plane. Okay, so we can directly insert into the equation, which is the vector equation for the plane is r dot n equal a dot n. Okay, so you already know your normal vector, so just insert into the equation. And then for the a dot n, you're gonna need to find the value, which is your a is -1 to 4. So you need to dot product the fixed point with your normal vector. So -1 plus 1 is -1 plus 4 plus 12. So the final answer for your vector equation would be equal to 15. Okay, so this is the equation, the vector equation of your plane. Okay, so now we are going to find the Cartesian equation. So again, we just simply need to change everything in terms of the column matrix. So your R is x, y, z, and then your I, your normal vector is 1, 2, 3. So the right hand side will still be the same, which is the dot product of a and n is 15. So x plus 2y plus z, 3z is equal to 15. So this is your Cartesian equation. Okay, so we're done with the first question. Okay, the second one, find the Cartesian equation of a plane that contains point A, B, and C. Okay, so this is the second case. Okay, second case. Alright, so we gonna need a fixed point, so we already have 3 points, so you can use either one. So what we don't have is we don't have our normal vector. Okay, so since this 3 point is on the plane, so you can just cross product two vectors. Okay, for example, let's say on the plane you have point A, B, and C. So let's say for this case, I want to find the cross product of A, B, and C to find the n. Okay, to find the vector n. Okay, so now we need to find your vector AB first. Okay, so your n gonna be A, B, cross product with A, C. So you have to find your AB. So AB is equal to O, B minus O, A. So your B is 3, 1, 1, negative 1, 2, 0 for your A. So the final would be 4, negative 1, 1. Okay. And then for your AC is equal to OC minus OA. So your OC is 1, 0, 3 minus negative 1, 2, 0. So you're going to get 2, negative 2, and 3. Okay, so now we're going to dot product the two vectors. Okay, so the AB cross with AC, we have I, J, and K direction. So your AB is 4, negative 1, 1, and your AC is 2, negative 2, 3. Okay, so remember that it will be plus, minus, plus. So for I direction, you're gonna have negative 3 plus 2I minus, in direction of J, you're gonna get 12 minus 2, J, and then for K, you're gonna have negative 8 plus 2. So your final answer for your cross product will be negative I minus 10J minus 6K. Okay, so this is your n, or your normal vector. Okay, so now since we already have fixed point, either A, B, or C, and we already have the normal vector, we're going to insert into the equations. So the question needs us to find the Cartesian. Okay, so let's first find the vector equation first. So r dot n equal to A dot n. So r dot n is equal to, so I just insert the column product. Okay, since we are going to find the Cartesian, right? So our n is negative 1, negative 10, and negative 6. So our A is any fixed points. So let's choose A as our fixed points. So it's gonna be negative 1, 2, 0, right? Negative 1, 2, 0, and we're gonna dot with the normal, negative 1, negative 10, negative 6. Okay, so for the left hand side, we have negative x minus 10y minus 6z. So the dot product for the right hand side will be 1 minus 20 plus 0. Okay, so negative x minus 10y minus 6x equal to negative 19. So I divide the whole equation with negative 1. So x plus 10y plus 6z equal to positive 19. So this is your Cartesian equation of the plane. Okay. Okay guys, so now we are at the last question. Okay, the final part for this video. Okay, so we are asked to find the vector equation of the plane that contains 2, negative 1, 3. Okay, so we already have our fixed point over here. So this is our fixed point. Okay, and then it also says that the plane is parallel to the plane with equation this. Okay, so meaning that we have a plane over here with the fixed point. That's fixed point 2, negative 1, and 3. So this is our fixed point on the plane. And then it says that our plane is parallel to plane with this equation, meaning that we have another plane. Let's say it's somewhere here, which is parallel to our plane. Okay, so it can be at the bottom or it can be at the top, it doesn't matter actually. But you need to know that it is parallel to each other. Okay, so the equation of our plane is 3x minus y plus z equal to 2. Let's say I label it as plane 2, and this is plane 1, which we are going to find the equation of the plane. Okay, so notice that for our second plane, we already know the normal vector that is perpendicular to the second plane. Okay, it has a normal vector. So notice that actually the normal vector for this plane is also a normal vector for our plane 1. Okay, let's say I draw it like this. So we have normal vector for this plane, but it is also perpendicular to the first plane. Okay, so this is our normal vector. Okay, now we are going to find our normal vector from this equation. So how do we do that? So looking at the equation, so this is Cartesian equation. Okay, so this is Cartesian equation of the plane. Okay, which is this left hand side we have r dot n, right? So our r is x, y, and z. This is our r. And then the a, b, c is our normal vector. So you have to identify what is your a, b, and c. So looking at this, we know that it is 3, negative 1, and 1. So that's how you know that your normal vector is equal to 3i minus t plus k. Okay? Alright. So now we already have the two things that we need. The first one is fixed point on the plane, and the second one is any vector that is normal to our plane. Okay, so now we can just insert into our equation. So we have r dot n equal to a dot n. Okay, so r dot our n is our normal vector for plane 1 is also a normal vector for plane 2. So this is their normal vector. So it is 3i minus t plus k. So equal to fixed point. So fixed point is 2, negative 1, 3. We're going to dot product the point with our normal vector, which is 3, negative 1, and 1. Okay, so 6 plus 1 plus 3 is 10. So this is the vector equation of your plane. Okay, we're done first part. Okay, now let's look at part B. So again, we have the plane with a fixed point. So now our plane is parallel to xy plane. Okay, so it's the same condition, but for this time it is parallel to xy plane. Okay, so remember that we have learned from the 5.1, which is, let's say I have 3 axes, x, y, z. Okay, so it says that our plane is parallel to xy plane, which is, this is our xy plane. Okay, this is our plane. Okay, so we have equation of plane that we don't know. Okay, so this is how it looks like. Our plane 1 is parallel to xy plane. Okay, so we already have the fixed point. Now we need to find the normal vector. Okay, so since it is parallel to xy plane, remember that if the vectors is on the xy plane, okay, the coordinate of z will be 0. But what we need now is we need a vector that is perpendicular, meaning that it is in that direction. Okay, so meaning that we can actually find a unit vector for this case, which is the normal vector of the vector that is perpendicular to the xy plane gonna have only one coordinate, which is to the z direction. Okay, so what will be the coordinate? The coordinate is 0, 0, 1. Okay, because it will only have coordinate at the z axis, but not at the x and y. Okay, so we already have the information needed. So I insert into the equation. So again, r dot n equal to a dot m. So r dot, our normal vector is 0i, 0j with 1k, so it is k. And then our fixed point is 2, negative 1, 3. So we're gonna dot it with our normal vector 0, 0, 1. So r dot k equal to 0, 0, 3. So become 3. Okay, so that is your equation of the plane that is parallel to xy plane.